We actually had a lot of financial services industry customers that told us that they really wanted the ability to scavenge massive numbers of really cheap cores using Spot across multiple AZs,
Mhm.
and they just wanted to be able to go out and harvest as many cheap cores as they could find. And the ability to cross multiple AZs was a key feature for them. So
It's really pretty drop dead easy to set up in Parallel Cluster. I do want to talk through some of the implications of these alternative heterogeneous queue designs. And to do that, I'm actually going to switch to some slides. Here is a simplified view of the queue that we just configured. Notice there are only C6I 32X larges in the queue, and they're all in the same subnet, all in availability zone 1. And since these are whole physical nodes or droplets, they can use EFA. And that's indicated by the little pink box that surrounds them. It's kind of like the force. So sometimes we need to use more than one of the same class of processor, even if the instance type is different. So what we can do is we can select multiple instance types when we configure our compute resource. The only caveats are that they have to be the same processor architecture, x86 or ARM, and they have to have the same number of vCPUs.
So a C6i is really nicely compatible in this sense with an M6i or an R6i because they
Mm-hmm.
really are more or less the same box with just different memory to core ratios.
That's right. And in fact, this is what it looks like if you do that. So on this slide, we've added M6i 32X large and R6Is to my compute resource. There's no operational difference. They all still have 128 vCPUs, so they can still, and so they're whole droplets. They can still be connected by EFA. But now we can draw on the availability pool for 3 instance types when we're aggregating capacity for this job. If you need to go even wider, you can start to do this by adding subnets, one for each availability zone that you want to draw from. You can imagine back to our configuration, only C6I, but now we've gone and we've added the 2 additional subnets. And this is what this looks like. So
Okay,
you might ask, why don't we do this all the time?
Matt, why don't we do this all the time?
Thank you, Stochastic Parrot. Notice that the little EFA box is gone. So EFA is designed for low latency communication. It's not possible to use EFA across availability zones.
And
You
this
don't.
is where we've got to explain it. An availability zone here is, these availability zones are miles apart.
Mhm.
And that is a good thing, because if some natural disaster befalls one of our availability zones, it's very unlikely to affect the other availability zones. So a fire, a flood, any other kind of horrible thing, a major power outage in a city. It's, for those reasons, we have different AZs, and spreading your workload across multiple AZs is a pretty serious affair because you're spreading your HPC job across miles and miles of distance.
That's right. So you can't use EFA because it literally doesn't make any sense to. So we simply don't allow it. If your jobs are loosely coupled, that means they don't need to talk to one another. This is okay. And a whole lot of workloads are pretty loosely coupled. Keeping in mind also that even if you can't use EFA, there is really fast networking between the AZs. It's just not EFA level fast.
Okay, now we might be jumping ahead a little bit, but it occurs to me this might have an impact on how we do our shared storage, right?
We will talk about how to configure shared storage in our next session, but it's definitely appropriate to talk about how your storage configuration might be impacted by the queue design. So let's consider 2 cases, Elastic File Service, or EFS, and FSX for Lustre, because those are super common storage solutions for HPC clusters. So the general concern when you're designing a storage setup to interact with your queues is minimizing the latency and maximizing the throughput of the file system read and writes. This is largely for performance reasons. But also, if you transfer data between AZs, there's also a charge. It's not generally a massive charge, but there is one.
Right, and of course it scales with the amount of data you're moving around, which in HPC could be quite a bit of data. So this is worth thinking about and planning for if you're doing this kind of architectural setup.
Yep. So let's start with EFS. Here's our original queue design with an EFS file system. All the nodes can use EFA, and they can connect nicely to EFS without cross-zone charges. That's why the little arrow is solid and green, and that's because EFS is replicated across AZs. When we have a design that spans AZs, that's right, the traffic is considered locally, so the connection to EFS is still shown here as solid and green. So now let's come around to FSX for Lustre and return to our original single AZ design. Here we're connected to an FSX Lustre file system, and it's deployed in a specific AZ. So FSX file systems aren't replicated. So the connection in this case, because it's in the same AZ as the compute fleet, is fast and green and won't incur cross AZ charges. But of course, FSX Lustre file systems are only deployed in a single AZ. That means if you expand your queue to span multiple AZs, it'll be possible for those instances to talk to your FSX Lustre file system. You can wire up the networking, and ParallelCluster will actually do that for you. But the compute nodes in the other availability zones will experience higher latency, potentially lower transfer speeds, and the traffic is going to incur cross-zone charges.
All right, so Matt, there's trade-offs to the multi-AZ queue design, but obviously they could be worth it under the right circumstances. Matt, thank you for that. There's a bunch of subtleties involved in doing a cross-AZ architecture, but the value of doing so is clearly worth it for a bunch of folks who've got an architecture where they really do want to go and harvest an awful lot of cores. But Matt, thanks for coming and explaining it to us.
My pleasure.
If you learned something from this talk, then please consider giving us a like and subscribing to the channel so you can find out when more videos like this are available. And if there's an area you'd like to see us go deeper into, don't hesitate to reach out and let us know. See you next time.